Welcome everybody to another great Sunday morning with PCI community calls. As you can see, we have the upcoming calls. We have our own Lynn Wells. I'm going to be speaking about enhancing network collaboration and closing the digital divide in April 11th. We have a few other things in the pipeline. And for today's speaker, we have our own Kevin Clark to thank for bringing him in. We're looking forward to that. And with that, I will have, probably most of us know this, but Kevin will be handling the facilitation of the question and answer period. And so just type your questions in the chat or raise your hand in the participants tab. Actually, one other thing I want to point out that we are beginning to consistently make these calls available publicly for those who can't make it or have other people think they might be interested. And so for now, we're only making the presentation portion of the call available. I just put the YouTube playlist in there, and we currently have 4 calls, and we'll be adding more. If there's a particular call from the past that you're interested in seeing, just ping me and I can prioritize that. So with that, I'll turn it over to Kevin.
Thanks a lot, Chris. And Ben, thanks for being with us. Let me just say, Ben Shneiderman is an innovator who's already in your life. His achievements in tech are things that you use every day. Clickable highlighted web links, high precision touchscreen keyboards for mobile devices, tagging for photos. He is a distinguished university professor emeritus in the Department of Computer Science at the University of Maryland. And he is a serial author in human-computer interaction and information visualization. And his scholarship for his new book, Human-Centered AI, is what brings us to him today. I met Ben as a collaborator in the Carnegie Foundation for Peace Net for Neighbors group, and as a fellow author in Design Thinking, Positive Use Cases for AI and Designing Presence. It's a great pleasure to introduce and to have Ben Shneiderman with us today. Ben?
Thank you, Kevin. Thank you, Chris. And thank you to the group for giving me this opportunity to talk. And I do have a prepared talk, but I'll take pauses along the way and take questions along the way too, and we can chat from there. So again, thank you. Let me start by sharing screen and let's get started. Okay, that should do it. Okay, so are you seeing it? Yes, I see it. Okay, I'm sorry. Good. Kevin's already mentioned I'm from the University of Maryland, but I'm coming to you from Vancouver, Canada, and been spending time here the last few years and connected up with University of British Columbia's Peter Wall Institute for Advanced Studies. And we've decided to be here rather than our busy urban Bethesda apartment during the COVID times, and that's proven to be very good for us and very lovely and comfortable place, although vaccines are slower to come here. I'm always pleased to wave the flag of the University of Maryland's Human-Computer Interaction Lab. It's now in its 38th year and 8th director, a wonderful interdisciplinary group between computer science and College of Information Studies and others around campus, including the wonderfully titled Maryland Institute for Technology and the Humanities, MITH. So that's the kind of interdisciplinary framework we come from. Kevin suggested my books have been influential, and this 6th edition of the book, Designing the User Interface, tells the story of the remarkable rise of human-computer interaction as an influential discipline. That's brought a lot of the technologies that we just use in everyday life, and that's been a great satisfaction to see happening. As he mentioned already, sort of my claims to fame, the easy discussions are about the highlighted link that we developed in the mid-'80s, and then the high precision touchscreen in '88, and to allow pointing at tiny screens. We started with a 9-inch screen down to 7, 5, and 3 inches, and reviewers of the paper didn't believe we could do a 3-inch screen. We made a video to demonstrate that. So it was a very simple technique that when you put your finger down, you got a cursor, you could slide it around and activate by lifting off. So lift off became the method. Steve Jobs visited our lab, and I became a consultant for Apple for 5 years. So I see how some of those things traveled. And the idea of the link of the photo tagging, the dragging a name from your list onto the screen and letting it drop to label it and then allow searching from that became our work. And I have the patent on that, which has traveled quite far. But most of my work has been about information visualization, development of the commercial Spotfire platform in the mid-90s, and the company formed in 1997, grew to 200 people in 2007, and was acquired by Tibco, remains among the leading visualization tools. Tableau, from my dear friends at Stanford, Pat Hanrahan and others, led the way to making Tableau, but Spotfire remains, for my money, most powerful tool around there and still widely used in high value applications. This is the tree map, is used by a company called FinViz to show the Standard & Poor's 500, all 500 stocks, area coded by the market capitalization and color coded by the change in price over the last time. I think this was from the day of the US election, and you can see the distribution of green and red boxes to indicate what's going up and what's going down. It gives a quick overview, lets you understand things. Our work on Node Excel, over 15 years now, led by Mark Smith. And we produced a book that's now in 2nd edition. It's the most widely used book for teaching network visualization and analysis. And finally, the work on medical, 10 years worth of effort on medical event visualization called Event Flow, which has spawned a new field there. So that's where I've come from. But today it's about where we're going. And my notion is that the field of AI has been growing and flourishing for 60 years. It's particularly strong in the days of machine learning and deep learning, and a great focus on the AI and improving the algorithms, but I'm into human-centered, as you will guess. And what I mean by that is that the goal is to amplify, augment, empower, and enhance people. Instead of measuring the performance of the algorithm, we want to see how we can measure the performance of people and make the performance of people more effective. We want more people to be more creative more often. We want to empower people to learn, to get medical care, and be in touch with families, and so much more. So, the vision that's emerged in the past year as I'm writing this book is, the goals we really should keep in mind whenever we design technologies are the human values we support, human rights, access to justice, dignity. And then beneath that, the individual goals, somewhat framed from Maslow, self-efficacy, creativity, responsibility, and social connections. These are what people want in life. And the way we're going to accomplish that is by making good designs that are reliable, safe, and trustworthy. That's become my mantra, my rhythm: reliable, safe, and trustworthy. There are about 35 attributes mentioned about AI systems, but I focus on those 3, and I'll go through them in more detail. And this is a comprehensive approach to thinking about how to accomplish that by way of software engineering teams, the larger companies, organizations they live in, the larger industries that all the companies are housed in, and then the government regulation that might occur. And our goal always is to keep in mind the diverse stakeholders, not just the researchers or the developers, but business leaders, policymakers, and of course, the users. So each one of these communities give us a different perspective on what we might mean by reliable, safe, and trustworthy, and what are the virtues we want. At the same time, we have to remember that there are threats, malicious actors of many kinds, criminals, terrorists, hackers, etc., oppressive governments as well. And there's also bias that comes in the data, in the programming, in the application, and flawed software that can appear. So those are the threats we have to work on. So those are the kind of environment I think about. And my focus has been in developing 3 approaches. The first is the HCI framework, which says it's not the computers that are going to take over, but we're going to empower people and give them powerful super tools and active appliances that will let them get their job done. And we don't have to trade off human control for automation. We can get high levels of automation and high levels of control. Second, we'll be shifting our design metaphors, not to think so much about intelligent agents or teammates, but to think about the way we give people superpowers. And the third will be what I've mentioned, the governance structures that will lead us at 4 different levels to making this happen. So that's the challenge. I've just turned in the book for production at Oxford University Press, but it will take 8 to 10 months for that to emerge. So stay tuned, but this is an early preview, and it's my thinking, which has been evolving rapidly over the past 2 years. And I look for the feedback from you to guide me as I complete this book project. So the first of the 3 ideas is the HCI framework. And it begins with a story from the first edition of my book in 1986, where there was a chapter that was described the notion of balancing automation and human control. And this was derived from Tom Sheridan, some of you may know, famed professor at MIT. And he was working with grad student Bill Verplank, and they developed the 10 levels of automation or autonomy, if you prefer the word. And the assumption was that you would move naturally from human control to computer automation. And your goal as a designer was to choose what point on this scale to set your sights on. How much automation could you get? That was always seen as a positive thing. More automation was better. And that notion is something I bought into, I wrote about, and described how it worked. And how to choose. But after many years and towards the 4th, 5th, 6th edition, I became very unhappy with that phrasing. I began to realize there was something else possible. And I changed, maybe I should say that notion has propagated. The notion of levels of automation continues. Here in the Society for Automotive Engineers, there are 6 levels of automation for self-driving cars. And so that idea remains firm in mind. And it also suggests a pernicious zero-sum game, that there's a trade-off to be made. But as I said, my notion began to shift and to say that we really should be ensuring human control while increasing automation. Ensuring human control while increasing automation. At first, even when I wrote this seemed like a bit of a puzzle to me. How is this possible? How could you increase human control? And I began to realize the way was there really were 2 scales. It was not a one-dimensional model, but there were 2. You could go from low to high human control and from low to high computer automation. That was the breakthrough in thinking. And it took me a few years to emerge and clarify what that could look like and how it was implemented in familiar systems. And so, this 2-dimensional grid now shows what may be possible. We could have low automation and low control, a music box or a landmine in the lower left-hand quadrant. We could have high automation, low control, where we think of things like the rapid deployment of an airbag or the continuous operation of a pacemaker might be totally under computer control, no human interaction. And that was, that's one model. And sometimes we do need that. Sometimes that's essential. On the other hand, there are some times where we want to be totally human controlled. I want to be able to ride my bicycle and play my piano and do those things, explore my efficacy, my mastery, and develop my creativity. And those are places I don't want the automation to constrain, limit, or direct me. And then there's this sweet spot of reliable, safe, and trustworthy, which has the balance of these things. So the simple notions of elevator, or maybe digital camera is my favorite example. Your digital camera has a high degree of automation for certain features, for setting the aperture, the focus, reducing hand jitter. All those are AI-driven algorithms that make it better. But on the other hand, the user has control of where they point the camera, what the zoom is, and the decisive moment when they click to get the picture they want. They took the picture. They have a high level of human control of what they want, and they have a high level of automation for the things that can be done reliably. And that began to open my perspectives about the way this idea could be applied. I realized also there were dangers. There was excessive automation over here, where if you put too much automation, then you get into real danger. The Boeing 737 MAX is, of course, the most familiar example, where the degree of autonomy was so great that the pilots did not even know that the MCAS system was in place and was engaged. And the feedback to the pilots was weak. The training was non-existent. They were just unaware. And as IBM says in its guide, invisible AI is unethical AI. And so, we need to make it visible and give users control. For me, that issue is essential. On the other hand, human control can lead to other dangers and people make mistakes. And so we may want to put some limitations, some guards, some interlocks. And the most familiar one is your self-cleaning oven in the kitchen, where once the temperature goes above 500 degrees Fahrenheit, you cannot open a door to prevent damage, to prevent danger. Okay, so those kind of things become part of it. And there are hundreds of those. Every mature design product has those kind of guards, whether it's a guard that limits you cutting your fingers on a power saw, or it's guards on aircraft that prevent pilots from doing many mistaken efforts. So this idea begins to propagate further, and we see it as a guide to design for pain control systems in hospitals. It used to be a morphine drip bag, just drip, 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 whether you needed it or not, whether you got too much or too little. And then automatic dispensers began to come in place. So automation that would control based on patient variables. But of course, pain is not easily measurable. And so you want to give control back to the user, and a trigger which allows the patient to select how much they get is there. But there's guards there as well. There's a limit to how many boluses, how many doses of morphine you can get per hour. And so that prevents the kind of dangers that might happen. But the more advanced notion is patient guided, but clinically monitored, that a hospital control room might have dozens or hundreds of these patient pain control devices, and they can monitor their use to see that they succeed, see how they're being used or misused, and what dangers there are, and how they fail. And so that kind of combined approach works to guide the design that's quite effective, that becomes reliable, safe, and trustworthy. And maybe take one more of a wheelchair design, or look at automobiles, but the old-fashioned wheelchairs were low automation, low power, low control. You required a caretaker to push the heavy wheelchair around. You may have seen them in museums, these quite heavy wooden wheelchairs that required someone to push you around. And then there became robotic ones that were highly automated, but you got less control. And then the hand-guided joysticks and even user-powered ones that users could move on their own. And so began the idea of wheelchair sports, wheelchair basketball, and Olympics. And those were positive things, but the approach you want to build in is the combination, motorized, joystick control, but possibly tele-operated, possibly programmable, and possibly monitored, so that you can know what's happened. Has the wheelchair fallen over? Does the person need help? And so these combinations seem to be a very effective way. So maybe I should just take a pause here. And is there any questions or comments about the idea of a two-dimensional model? Some have suggested maybe I need a three-dimensional model, and these things will vary based on the consequences, whether they're lightweight recommenders, consequential applications, or life-critical things.
Any questions for Ben at this moment?
You know, a question is, how do you, Lynn Wells here, how do you know, kind of your point about invisible AI is an ethical AI? And I guess what kind of feedback loops you have, maybe the cybersecurity, the AI algorithms, to if you set these goals, what kind of protections do you put in place to make sure that they're stable over time?
Well, designers don't always put them in place, but that's really what we want. We want to have the information about what's happening. Cybersecurity is a good area, and there has been developments, but to be able to monitor a network took a great deal of effort. The belief was the networks would operate automatically on their own. But even quite early on, the idea of certs and control centers for network operation began to emerge, and the ways of visualizing performance and problems began to grow. It's still slow. I mean, I'm going to come to this very soon, but that's what we need, is a greater degree of control. Look, I want it at home too. When my Wi-Fi fails, when my connection disappears, I don't get a clear message about what's going on. And so I have to go begin to debug it. Is it my machine that's gone wrong? Is it the Wi-Fi? Is it the router? Is the network provider? And so, we are mystified. We're kept in the dark about what the systems are about in many cases. Actually, Cloudflare, I understand, has such a display panel for its operators. And there are, I hope, a growing movement towards providing the kind of visual information that lets the people, the stakeholders, understand what's going on.
Mhm.
Is that what you had in mind?
Yes, that's very helpful.
Yeah, I'm a great believer in visual,
Yes, thank you.
information presentation and status displays so people can monitor what's happening. The 737 has many parts to the story, but basically the pilots were not informed that the MCAS was engaged, and they just didn't know the status, nor were they given options on their displays about how they could shut it off. They could shut it off, but in the terror of the moment, they just didn't know what to do. In one of the cases, they pulled on the stick 20 times in the minutes before the plane crashed. And each time the plane pointed nose down till it ultimately tragically crashed into the ocean. So this model is a helpful one because it reminds you about the range of possibilities. It's not a simple linear notion. You don't have to give up control in order to gain high levels of automation. Even things that we thought of as being automated, like pacemakers and airbag deployments, have come under greater supervised autonomy, as Tom Sheridan would call them. And we track what happens. We track what goes wrong. If we're going to have the need for high degrees of autonomy, like in the 200 milliseconds for deployment of airbags, we need to have much better monitoring of what went wrong. And as many of you know, I mean, airbags in the early days saved 2,500 lives in the US each year, but they killed about 100 children and elders because of inappropriate deployments. And only once that was understood were the changes made to put a sensor in the passenger seat and then shift baby seats to go into the back. And so those changes happened, but they happened too slowly because the information about where the failures were not widely known. Okay? It only happened once the emergency room data was collected in aggregate to begin to understand what had gone wrong. I might say to you, for example, I'll ask you, how many deaths you think have there been from Tesla cars?
Under 10.
Under 10, I heard. Yeah, and that's what I thought too. I mean, we have some highly, notable one, the 2016 crash in Florida. It's others. So those get noticed. Well, there is a website called Tesla Deaths. Check it out. Tesla Deaths. Last time I looked, there were 164. And that makes you stop and think. Now, not all of them were while autopilot was engaged. In fact, we don't even know how many happened while autopilot was engaged. But there have been more deaths than you would think. And there are more surprising and unexpected accelerations that happen. Typically, people pull up to their garage and instead of the car stopping, it flies through the wooden door of the garage and smashes to a halt in the back on the concrete wall. There's 122 of them on the National Highway Transportation Safety Administration's website. So, you know, having these incident reports, I'll come to in a moment, are really important. All right, I'm just saying we need to have the data to make wise decisions, and we need to understand what, you know, what the choices are. The second point is about design metaphors. It ties off of this. Once we're given the freedom to look for the two-dimensional models, what do? Well, you know, we have these two competing and let's say productively collaborative. The notions of intelligent agents are powerfully emplaced, and teammates, collaborators, robots will do it all for us. We'll have assured autonomy, not just autonomy, but assured autonomy, and social robots will become our friends, caretakers, and childminders. And this is one vision of the world. I don't share too much of that. And I would suggest in the language I use here is the notion that there are super tools, tele-operated devices, supervised autonomy, and active appliances. And so I won't go in great length about these, but these are two different views, and there's some value to be gained from each of them. And what I hope to contribute is to strengthen on this right side of the image. So, you know, some of the examples of what I consider to be super tools are your camera again. You get enormous degree of control over features before you take the picture, after you take the picture, how you share it, what the picture is going to look like. You can edit, you can change, you can filter, you can darken, you can lighten, you can crop. There's so many ways you're in control, and yet there's a high degree of automation and powerful AI algorithms at work. Similarly, the navigation choices. You're going to go from the White House to College Park, the University of Maryland, and you get 3 possible routes, and you can then choose, and you get a model, a predictive model of what's going to happen if you do it. That's really right. Predictive models that show you what's going to happen are the right kind of design. And yet a lot of the robot systems don't offer a view of the status or the future direction. Yet we know that's very powerful. Those are important results. Similarly, in little ways, the search query completion gives you choices, and then you can select from them or not. Keep typing, and spelling correction, translators, all these have wonderful AI algorithms built behind them, but the user interface keeps them user-centered, keeps the user in control. And so that's the central notion here. And the extension of active appliances, these humble kitchen appliances, no longer so humble, but increasingly programmable and powerful, let you do a great deal, and in the future will do a lot more. Again, increasingly AI embedded, sensors and all these devices, feedback from reality, continuous changing, pattern recognition, and it provides a powerful service. But again, you have the sense of control. You know how many minutes it's going to take to complete the cycle, and that's the key thing you want. I mentioned already, pacemakers have gone from being an autonomous device to being something controlled from your phone and monitored by your physicians and clinicians and the manufacturers as well. And even things like Mars rovers and the Perseverance, they have a degree of autonomy, a good degree, that they can move around on the planet, they can avoid obstacles and precipices, yet there's a whole control room of operators back at JPL who are monitoring what's happening and making it happen. Surgical robots are highlighted mostly by the press as doing surgery, but the manufacturer, and I've been in touch with them, robots don't perform surgery. Your surgeon performs surgery with Da Vinci by using instruments that he or she guides via console. And that's a kind of important notion here. And so there's a misleading vision we have that needs to be corrected to make these kind of successful designs. Bloomberg Terminals, another great example, highly visual space, and 300,000 people pay $20,000 a year to have this on their desktop because it's so valuable. All the information, mostly in a spatially stable, mostly in a tiled approach, gives them the information they want, where they want it for rapid access and quick decision making, and then quick execution. And so this is what I want, not a teammate or a partner that I chat with, but a powerful tool that takes advantage of high resolution displays and offers me what I need to make my decisions effectively. And control centers, counterterrorism centers, transportation network, utility centers, et cetera, all have this. People working together, cooperating with huge amounts of information available to them. Okay, the third structure here is the governance structures. And, how do we manage this comprehensive process? This is going to take a while to implement, but there's this 4-level model. The 4 ovals here that start at the center, the things that software engineering teams can do. Sorry about that. The organizational contents, they're team members, many teams work in an organization. The organization can set up a safety culture to make this happen more reliably. Within each industry, whether it's medical or transportation or military, legal, financial, you'll see a set of systems in place to make sure things go well. And then government regulation is the larger oval around that. So these are the structures. The paper on this has 15 recommendations. I won't go through all of them, but the first batch of them about reliability based on software engineering principles will talk about 2 of these things. And then there's more you can dive into to go further about that. The organization level is safety culture. I won't have time to talk much about that, but I think you may know the principles about safety culture. It's a leadership prospect with substantial investment cost and personnel. However, the payoff is of reduced injuries and the competitive advantage of safety cultures, successful safety cultures, is well understood. And so I think that becomes an important set of criteria. And then the trustworthiness is certified by others external to the organization. And so accounting firms are stepping up to be the auditors for the AI systems. Insurance companies are beginning to figure out how to compensate for failures. The risk profiles are hard to assess still. Don't have enough data about the failures of AI systems. So, I mean, there's a very interesting project called AI Incident Database at the Partnership for AI, already with more than 1,000 incidents of things that have gone wrong. And so that becomes important. And the question, a simple question I'll get you to think about this: how much would it change the self-driving car industry if insurance companies announced that they would have lower premiums on cars that were self-driving? And what would it do if they announced that they gave higher premiums for cars that were self-driving? Would that accelerate progress in making them safer? After all, I mean, self-driving is the advertised goal, but I would say safety first is the goal that I would like to see for cars. And I think the insurance companies could provide a valuable role in dealing with that. And then, of course, government interventions and regulation do not always have to be pernicious. The AI industry has spread a strong fear of regulation as a limiting force for innovation. And that is, of course, a threat. That's possible. But we know that proper regulation produces high degrees of innovation, as it did for automobile efficiency, fuel efficiency, and for safety. Those were enormously successful. The companies didn't want to do them, and now they're very proud and they advertise their successes in doing that. So I've mentioned already the idea of audit trails, a flight data recorder for every robot, and not only for retrospective analyses of failures, but also the understanding of near misses. What did the pilots do in order to prevent a disaster? In fact, in the 737 MAX, a few days before the first crash, a pair of pilots actually ran into the same problem, but they managed to figure it out and save the plane. but that knowledge did not get disseminated. So better understanding of near misses would be a great help. And then it turns out MITRE Corporation collects all of the flight data recorder information, and from that comes better advice about preventive maintenance activity. I'd like to just one more topic and spend a few more minutes on explainable AI and explainable user interfaces, a large and important topic these days. DARPA's HCAI, Explainable AI project, is quite visible, and the general direction taken for those 11 projects is retrospective explanations, often called post hoc explanations. That is, you apply for a mortgage or for a job and you're told, no, sorry, you didn't make it. And here's the reason why. So you get an explanation. The European GDPR regulation requires that citizens receive explanations. So that's a growing awareness in the last 5 to 7 years, a huge explosion of research papers and conferences on explainable AI. But as far as I can see, mostly about post hoc explanations, which I've come to realize are not the optimal way. You may need that, they could be beneficial, but I would say the right goal is to make interface design of control panels so that you can prevent the confusion and surprise. And we should talk about prospective, or sometimes called anti-hoc user interfaces that are, again, interactive, visual, and exploratory. Let me show. So here's a typical post hoc report for a mortgage loan. You put in the amount you requested, your household monthly income, your liquid assets, you press the submit button, and you get a result. And it says, we're sorry, your mortgage loan was not approved. You might be approved if you reduce the mortgage amount requested, increase your household monthly income, or increase your liquid assets. So that would be considered a pretty good post hoc explanation in this simplified case, only 3 variables, but that gives you the idea of what I have in mind. So that's kind of the current situation. My proposal is that you have a user-controlled prospective user interface that allows you to slide the amount you're asking for, and then you'll see how much the blue goes up or down. Change your household monthly income. What would happen if you increased your monthly income? And what would happen if your liquid assets were greater, if you could borrow some money from family members? So your goal is to move that blue line up to the green line, and then you know you're going to get it. So this gives control back to the user. And I think it's just a fundamental philosophical position that I take that comes from the world of human-computer interaction, to say, give the user control, let them explore the alternatives, just as you do with a GPS navigation system, and you get to choose what you want, and you get to see the implications of the decisions you make. This notion has become widely used in many recommender systems. I wouldn't say widely. It's used in some creative ones. There's still a resistance, though. But the idea of a control panel. So here is a wonderful group of British librarians who set up a great website. Give it a try, called whichbook.net. Lets you choose novels by sliding these controls. You can choose up to 4 controls: funny versus serious, beautiful versus disgusting, no sexual content, explicit sexual, optimistic versus bleak. And as you move these things, the covers change on the screen immediately. So you get the feedback immediately. You have a sense of exploration. You know why you get a result. You don't need to ask, why did I get that result? You can see it right there because it's under your control. Okay, so that's one. As another example, there are about 25 studies of such systems that all show their benefits. This is the Spotify music choices. There are 14 variables that Spotify uses. This study only gave users control over 5 of them, and you can change acousticness or danceability or energy and slide them, and you'll get the changes coming here. Similarly, OECD's Better Life Index comes with a set of sliders that way. So that's the notion. That brings me to the close and the summary. And I just repeat, there's a systematic way of thinking about this that's very different from the current AI belief that the robots will take over, they'll be in control, And I'm a great believer in human-centeredness and human control. And so, my contribution here is the HCAI framework, the two-dimensional model that opens up the design possibilities, the design metaphor that gives us another way of thinking about design that focuses on super tools and active appliances, and then the governance structures that puts this to work in a substantial way. So that's kind of the pitch. It's coming along. You can read about my position in a wonderfully done article by John Markoff in the New York Times from last year. So that will give you one source, but if you want to dig deeper, the papers that appeared in the past year that contain the beginnings of these ideas are out there, and they've been widely read and downloaded and referenced. So I would say we're still at an early stage, but the growth of human-centered thinking, the Stanford Human-Centered AI Center, and 20 other universities that have, and research groups that have adopted various forms of human-centered, humane, responsible, ethical AI. All these words are coming into fashion. I hope to coalesce thinking around the notion of human-centered AI as a fresh way of thinking about design. And that's the pitch. I hope these ideas, I can start this going. I'm the match maybe to start it, but I need you all to take these ideas and say, yes, it can work. And next time you work with some other developers, you say, hey, what about this? There is another way to think about it. There is another way to think about it, okay? And, the robots will have a lot better design of advanced automation if we focus on a human-centered approach rather than making machines that are replacing us. But I think we have a positive future. There's lots of work to be done. So let's get on with it. And thanks again for giving me the chance. Glad to discuss with you.